Okay, the effective stress analysis comprises of three cases for consideration. The first one is without tension crack, and this equation is general equation. So this will be the basic equation for F or S for effective stress analysis. Okay, then the question also can ask you about with tension crack without water. In that case, you need to find the value of Z0 first and then do some modification with the area. So that is why we have the value of gamma W dash and alpha dash. Okay, meaning that you need to do some modification, and then also the modification to the uh, W sine alpha, which is alpha dash. So we need to do modification to the equation. And then you have the case for tension crack with water. And as we have mentioned before, that the tension crack with water will additional information or additional equation that is PWYC over R. So you need to remind yourself what is the meaning by PW and then YC. So PW is the equation for force of water, which is half gamma water Z0 squared. And then YC is the length from the force of water to the centroid of your diagram. So next we need to look how the example for this particular problem. So as I have mentioned before, the possible cases is ignoring the presence of tension crack with the presence of dry tension crack, and then with the presence of wet tension crack. Okay, that is another way to describe with tension crack without water, and then with tension crack with water. So of course, the same method that you want to use, the first thing is to gather all the soil parameter, for example, the value of C, the value of friction, which is a phi, and of course the radius for the circle, whether you calculate from equation theorem Pythagoras or you measure from your graph, that will be the measurement. The ruler itself will give you the measurement of the radius, and then of course the value for unit weight of the soil. Okay, next is to draw the drawing on your graph paper. So draw according what have been told in the graph paper in the question, and then transfer to the graph paper using appropriate scale. So you can actually draw the same the drawing process is the same. So you need to identify which points that important, the measurement from the question, and then transfer to the graph paper. So in this question, the question asks for you to divide to 5 slices. So this is how you should slice the slope. And of course, we need to calculate for the area and to position the H. So for triangle, you need to position the H, the height of the triangle, at the 1/3 of the triangle. And then for trapezium, you need to position at the center. So you need to determine all of these position first. So you have the strip number 1, strip number 2, strip number 3, and then strip number 4, and you get the last one will be strip number 5. Okay, why we need that position? Because we want to calculate for the value of alpha. Okay, before this, you are doing the measurement of the distance d, but for this ordinary method of slice, we need to find the value of alpha. So from the position for each slice have been shown, and then you need to draw the pink line, which is from the centroid, and then make it pass from the line that you have drawn before, and then from the center to the pink line, that will be the value for alpha. So you need to do this for every of the position of your slice. So you have alpha 1 to represent the position of slice number 1. Alpha 2 is the position for slice number 2. And then you have number 3, alpha 3. So alpha 4 and then alpha 5. So each of alpha is the value of angle. So you need to use your protractor to find the value of each alpha. So next is to know what is the value of alpha positive and negative. Okay, whatever in the from the center to the pink line to the left, that will be that is negative value. So we have slice number 1 and slice number 2 negative value, and then slice number 3, 4, 5 will be positive value. Okay, that is for this example. So next is to determine the value of theta. So you need to use the protractor. Okay, and then find the value of theta. So this information you need to transfer to table. Table is always we always advise you to put all the data in the table, because the table will give you a very neat way to present the data. So this is the thing that you need to include in the tables. You are referring to strip number 1. Okay, you need the width for the strip. You have the height of the strip. Calculate the area. Depends on the shape of the strip or slice, and then you get the value of the area, and then transfer the value of alpha. Next is to calculate for W sin alpha and also W cos alpha. So at the end of the process up to slice number 5, okay, you must total up the value of W sin alpha and then total the value of W cos alpha. And the last part is to put every information that you have in the question and the graph paper and to calculate in the equation here. So C times length of arc CC plus W cos alpha multiplied by tangent phi and divide by W sin alpha. So C is the C cohesion value. Length of arc is R, which is your radius, multiplied by theta, which is the angle. And those value must be calculated in radian, and then you calculate, put all the information in the equation. You get the value for F or S, that will be 1.65. So that is for the value of F or S without tension crack. Okay, next, if you have tension crack, okay, first find the value for Z0 or tension crack depth, and you need to use the equation of 2C over gamma square root Ka. That will be the value for tension crack depth. Okay, put the information and then you get the value for tension crack. So that value, which is in this example, you get the value for 2.57 meter. Position that in the graph paper. Now we can see that strip number 5 will be modified into new shape, and we are using that measurement of Z0 to determine the new shape for slice number 5 or strip number 5. So next is to calculate the area for slice number 5, and of course to position. The blue line here is the position, because right now the slice number 5 have been changed from triangle to trapezium, so we need to position at the center of the trapezium. So next, what you need to do is to draw the red line from centroid to the length of the tension crack depth, and we will get a new value for theta, which is theta crack is equal to 106 in this example. So next we need to determine the new length of the slope, and of course we need to modify the value for the length of the slope. So in that case, we also need to do the modification for the slice number 5. The alpha should be different because of right now the position of the slice number 5 is now at the center of the trapezium. So use the same method from centroid, having that pink line and then cross that blue line, you get the angle of alpha 5. So now we need to put this in the table so that you have the modification right now is slice number 5, and then you get the new value of for alpha, new value for W sin alpha, and then new value for W cos alpha for slice number 5. So right now, to solve for tension crack without water, the value of strip number 1, 2, 3, 4, and then plus number 5, the new value for number 5. So next, use this information, put it inside the equation, and then you get the new value for F of S. So of course, sometimes they might ask you the question for tension crack with water. So use the equation given, because the modification we have already done, but right now you need to put another equation for modification with tension crack with water. Okay, the last part for this discussion will be slope protection works and strengthening system. Okay, this is the thing that we want to ensure that our slope is stabilized, or whatever it is after you have done your construction or design in slope, and we need to do some modification if there is some uncertainties in your construction. So this is the things that can be done, the slope protection work and strengthening system. The first one is unloading and changing geometry. So instead of having a very steep slope, you might want to change the angle of the slope so that we don't have that kind of so steep in terms of the slope angle. And then we can use structural stabilization, improving drainage, slope reinforcement, soil improvement, and vegetation. You can explain how we want to use unloading and changing geometry. So the first one is the slope stabilization. By unloading, you cut some portion at the top of the slope. And for B, reducing slope height. Okay, and then you can flatten the slope. So we are reducing the slope height. And for number B, increase slope ratio, and number C is using lightweight fill. So a lot more things that you can do. You can refer to this figure to give some information for changing geometry and unloading some of the load on the top of your slope. For structural stabilization, you can use external stabilization system. For example, resist the applied earth load by virtue of their weight and stiffness. For example, gravity wall, creep wall, and sheet pile wall. And then internal stabilization system. Internally stabilized system reinforce the soil to provide necessary stability. For example, soil nailing. So these are the examples. You can see that we design for the slope. In the front of the slope, you have the retaining wall, and some can use the anchor system. So it kind of like you nail the soil, you are using a tie rod, or you are using steel rod, and then you are putting it inside the slope. So that is kind of like nailing that still rot inside the slope area. So this is the surface of soil nailing. The face of the slope is right now is the soil nailing system. So you can see that a lot of rod has been installed inside the slope, and you can see this is quite steep slope. So this kind of strengthening system is very much needed. And next, what you can do is to improve drainage. Okay, of course, this is a must for the slope, especially if you install retaining wall in front of the slope. So we need to ensure that the slope is properly drained out if water exists behind the slope or exists in the backfill of the retaining wall. So what you can do is to provide for surface drainage, and then of course you can also provide for subsurface drainage. So this is how you install the subsurface drainage. And of course you have that subsurface drainage, we call it as perforated drain, and then you have surface drainage to drain all the water out. Okay, and then this is the system for surface drainage. It is on the horizontal direction of your slope, and all the surface water must be uh, follow the flow, or we must provide surface drainage so that the surface water can use the drainage to drain from the slope system. So a good surface drainage system captures surface water and carries it to a safe discharge point and not seeping downwards into the slope. So this is what we want from the design of the slope and when we provide for the surface drainage. For slope reinforcement, other than retaining wall nailing that we already discussed earlier, so you can provide slope reinforcement. Retaining structures such as pile, wall, and anchor may be used to improve stability. And of course, we are using geotextile to reinforce for the slope system. So in this drawing, it shows that slope reinforced using polyfelt geotextile. So we are putting or we are installing the geotextile by layers. So it will enhance the stability of the slope. So other soil improvement is the application of chemical or mechanical treatment. Okay, for example, you are installing or you are putting Gynite spray for the surface of the slope. And of course, a lot more of the method that can be used on and can be used in the site. Okay, this is more likely to eco-friendly way of protecting your slope. So we are installing vegetation, and of course we will select suitable plant or suitable grass to be installed on the surface of the slope, and we need to ensure that that grass have vertebral root system, which is can grow to the slip surface area of the slope. And of course, if you can provide grass which can help you to do the maintenance easier. So the information is here. Vegetation is an important part of most slope stabilization plan. It provides erosion protection, draw a transpire water out of the ground, provide some reinforcement of the soil, and most the important thing is the aesthetic value. So for that, that is all in terms of discussion needed for